All right, so I'm going to skip the last example of 3.3 or section 3 because we're going to do that one in class before we do the worksheet for part 3. And we're going to move on to part 4 or section 4, which is measures of predictive power. So we just spent a lot of time talking about how to get a prediction from the line, what the slope tells us, but nothing really tells us if the line itself, this regression line, is doing a good job. We can get a single residual and know if we did a good job predicting for that one value, but we need to know if the line is good in general to be using to make conclusions about a population, whether it's a prediction or just that general relationship with the slope. So there's two ways to look at our predictive power. One is to do a residual plot, and the other is the coefficient of determination. So residual plots, they allow us to see all of the errors simultaneously. So that's why residual plots are really awesome. So maybe we did great in predicting for one person, but how did we do overall? So at this first residual plot example, it's just a scatter plot where we have the different x's and then the residuals, which is our error, right? So like this point right here, this was perfectly predicted. If we just looked at this person, we would think our line was badass. But then when we look up here at this person, we're going, oh, we were off 2 for that person. That's a bigger deal, especially depending on what the actual units are for our y. So the first thing you want to look for in a residual plot is unusually large values. And this really depends on our y. On our y. Because look at this graph below. We can see our residuals look like they go from about a plus or minus 2, right? So this one says error is plus or minus 2, which would be great if y was weight or systolic blood pressure. Plus or minus 2 seems pretty reasonable. But what if y is GPA? If our y is GPA, then this is crap, right? This would be being like, oh, your GPA is somewhere between 0 and 4. And you'd be like, yeah, because that's all the possible GPAs. So it really depends on what the units and scale of your y variable are in the first place. So pay attention to that and just sort of think about in context, is plus or minus 2 a good range to be in while we're making predictions? The second thing you want to look for is curvature, because what's happening when you do a residual plot is, remember, we're looking at those vertical distances. That's what our residuals are. So if we originally had an x and a y, and we fit a line to data that looks like this, these vertical distances are going to look exactly like what's going on here. So if you see a curve in your residual plot, that means there was a nonlinear pattern in your original plot, your original scatter plot, and you shouldn't have done linear regression. So the curve tells you that, oh crap, there wasn't a linear relationship in the first place, and I applied a linear model. So we don't want to see a curve. We don't want to see large values. We also don't want to see what's called fanning. So fanning is uneven variation, and this means we did really good at predicting in the low end of x, but we're doing really poorly predicting in the high end of x. We can see this sort of fanning out as it gets towards the larger x values. Now this can happen in the other direction as well. You could definitely have something where the predictions are crappy at the beginning and then they get better and better. A student in another class asked me, what could you think of as an example where that would happen? And I said that same one that we've been using as an example, hours studied versus exam score. Because there are some people who are not going to study very much, but that's because they have gotten enough out of coming to class, watching the videos, that they're not going to spend a lot of time studying and they're going to nail it. And there are some people who are not going to spend any time studying, they're going to just bomb it. So we're going to see a sort of huge variation at the low levels of studying. But at some point when you're studying a lot, hopefully if we're studying effectively and using all the sample exams that I'll post on Blackboard, we should do a better job of predicting what your score is. So that might be an example where our fanning goes in the other direction, where we do a bad job on the low end, but a great job on the high end. The last thing you don't want to see are individual points that seem like they're off the trend or out from normal. If you have somebody who has a really high residual and nobody else does, then you're sitting there going, that means they were really far off the trend in the first place, and we know outliers can cause some havoc when it comes to linear regression. So influential observations are just things that seem outside of the norm. In terms of your residual plot, what you want to see is something that looks like this. So we have pretty small values. Again, it would depend on our y, but these values look pretty small. Our variation is sort of all over the place. There's no fanning, no pattern. This is what you want to see. It should look random. All right, that's the goal for our residual plot.